Okay, we're going to take a look at trig in the unit circle. So we've got a unit circle here, and we're going to see how it connects to the sine function. There's a red line here, and this is my radius. And so A, the slider A, basically represents my radius and the angle that it makes with the circumference of the circle. All right, so as we move A and slide A, we get around 50 degrees there, so it's making an angle of 50 degrees with the circumference and 90 degrees and so on. Now, if you take a look right here, you'll see that the sine A is giving you a value, which means that that's the value of the function at that particular angle of the graph. So sine A at 47 degrees is 0.73. So sine is 7, and you can check this with your graphing calculator. If you put sine of 47 degrees into your calculator, you will get this value. The question becomes, why is it that? And so we're going to take a look at, we'll stay with this point, which is 0.682 and 0.731. Remember that the sine ratio is opposite over hypotenuse. So opposite over hypotenuse. There's my opposite side, because we're using this angle here, remember? And there's side hypotenuse. Now, so if we take a look at the function of sine, we know that it's O over H. And if we take a look at our graph, we have this right angle triangle. And so we can use the sine function. And the thing is that opposite, which is this side here, we know what that length is, because if we know this point, then that's just 0.731, because it's just your y, right? It's just your y across there, 0.731. And we also know what the hypotenuse is, because the hypotenuse is 1. It's the radius. So there's sine of A, which is equal to 0.731 over 1. Now if you put that into your calculator, 0.731 over 1, and you put in, it's basically we're trying to find, we put in the negative function. So if we do that, if you go to your calculator right now and you put sine of negative 1 in, of basically 0.7331, you'll get a value that's 46.97, which is this, basically, the 47 degrees. So as we move along this unit circle, as A moves along this unit circle, what's happening is we're basically doing right angle triangles all along here, which relate to O over H. So when we get to every position, it's basically working this every single time out for you to show you that that ratio is going to give you that angle. And so that's why sine ends up being this, 0.731 blah 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 over 1. That's what sine is. It's this. It's at that position. Okay? Because that's basically your y value as you go.